It's the Ferguson system that makes the difference. A demonstration like the one you are about to see could be held right on your own farm and will show why the Ferguson tractor with the exclusive Ferguson system of implement control gives you much, much more than just a tractor. Yes, most tractors look somewhat alike, are mass-produced under rigid inspection to give the customer a quality product. But the Ferguson tractor has that added feature that permits a relatively light tractor with easy maneuverability and economical operation to do the work of a much larger tractor. But let's not just talk about what the Ferguson system can do for you. Let's get on with the field demonstration and actually see for ourselves. After you have seen this motion picture, maybe you would like a demonstration right on your own farm. We would be glad to give you such a demonstration at your convenience. The Ferguson system of implement control includes a great many parts, all integrated and working together. Inside the tractor, sealed from dust and damage, is the ram cylinder, the hydraulic pump, with exclusive suction side control, which gives that smoothness to the operation of the hydraulic system. Also, the control valve linkage, which permits the operator to manually move the control valve by means of the fingertip control lever, and the implement to automatically move the control valve when the tractor requires additional traction to pull the load. This conveniently located fingertip control lever permits easy raising and lowering of the implement, as well as selecting the working depth. An easily positioned stop locates the selected position each time the implement is lowered. The stop may be bypassed to maintain the depth in harder soils. If lighter soil is encountered, the fingertip control lever may be raised slightly above the stop. This single lever permits an instant and effortless adjustment to meet variations from light to heavy soils. The implement is attached to the flexible three-point linkage, which carries and controls the implement. There is the left lower link, the left lift arm and rod, the master control spring, the top link, the fingertip control lever, and the right lift arm, leveling rod, and lower link. These are the external parts of the Ferguson system of implement control. The conveniently positioned fingertip control lever permits raising and lowering the implement by hydraulic power. By means of a special demonstration lever, the operator is putting pressure against the master control spring to simulate the pressure that is placed against the control spring when the implement is being pulled through the soil. The action is purposely exaggerated to make the movement visible and to show the principle of the system. As the implement is lowered and reaches the depth selected by the fingertip control, the pressure on the control spring stops the lowering. The weight of the implement plus the soil suck is carried on the tractor through the lower links, lift rods, and lift arms. This increases the tractive weight of the tractor in proportion to the size of the load to be pulled. Now let's take a closer look at this action. As more pressure is placed on the control spring, the implement starts to raise. Actually, in the field, this action does not raise the plow noticeably. Instead, it pulls the tractor down more firmly against the soil to give the additional traction necessary to pull through a hard spot. If the soil texture varies considerably so that the plowing depth does change appreciably, the operator simply moves his fingertip lever slightly farther down to retain his selected working depth. An extreme impact pressure on the control spring causes the implement to drop as demonstrated by the operator. Here we again see the operator demonstrating the principle of the Ferguson system, showing in more detail the overload release which protects the tractor, implement, and operator when striking a hidden obstruction. The great impact from striking an obstruction compresses the control spring beyond its normal range and the oil pressure is lost. The implement rests on the ground, thus reducing the traction of the rear wheels, and they spin harmlessly. We have seen that the Ferguson system has provided 1. A fingertip control lever to raise and lower the implement, as well as to select the working depth. 2. Flexibility between the tractor and implement. 3. Increased traction as required which enables a relatively light tractor to do the work of a much larger tractor. 4. Automatic protection for the implement, tractor, and operator when the implement strikes a solid obstruction in the soil. Now let's see these demonstrated under actual operating conditions and find out what they can mean to you. Our demonstration plot requires about 2 acres. On each side of about 1 square acre, we will make a back furrow or strikeout. These will be ridged high for a later demonstration. Across the direction of plowing, we will cut 2 grooves or ditches representing dead furrows, drains, washes, or other surface unevenness that could be found in some fields when plowing. In the center will be our dead furrow or finish. Here is the final proof of the pudding. The operator is driving at full plowing speed along one side of the demonstration plot. As he crosses the ridges and ditches, the flexibility of the linkage permits the plow to move along level, while the tractor follows the unevenness of the ground surface. The furrow bottom is level, so that a uniform depth of seed bed will result when the field is disked or harrowed before planting. Watching this again in slow motion, we can study the action. As the front wheels drop in the depression, the pressure against the top link decreases and some oil is released from the ram cylinder. As the front wheels come out of the depression, the pressure on the top link increases and oil is pumped back into the ram cylinder. This is repeated as the rear wheels pass in and out of the depression. This controlled flexibility between the tractor and implement produces a uniform furrow bottom even when operating across uneven ground surfaces. Watching again from the side, we can see the tractor rising and falling as it crosses the depression while the plow moves straight along. Notice the lack of rear wheel slippage, which is evidence that the plow is still being carried on the tractor for additional traction during this period when flexibility is also required. This controlled flexibility between the tractor and implement may be compared with a hinge stick. As the front wheels drop into the depression, the pressure on the top link decreases, allowing oil to escape from the ram cylinder. Thus, the front of the tractor can hinge downward without pulling up on the plow or moving from its level position. The front stick held by the operator represents the tractor and the rear stick the implement. When the rear wheels drop into the depression, more pressure is exerted on the top link and oil is pumped back into the ram cylinder. This keeps the plow from going deeper, and the weight of the plow and soil is carried on the tractor for traction. As indicated by the hinge stick, the tractor is hinging upward, again leaving the plow level. The Ferguson system provides that extra traction when required, so that a relatively light tractor can do the work of a much larger and heavier tractor. As the operator disengages the power takeoff which operates the hydraulic pump, the effectiveness of the Ferguson system is lost. Traction is reduced and the wheels spin. Re-engaging the power takeoff regains the tractive weight and plowing continues normally. Demonstrating this again a little slower, we see the tractor plowing normally. The operator then reaches down and disengages the power takeoff lever. Now, as he continues plowing, the rear wheels begin to lose traction and slippage becomes excessive because of the loss of tractive weight. Re-engaging the power takeoff to again make the Ferguson system effective regains the necessary traction to continue normal plowing. Our relatively light tractor is now doing the work of a large, heavy, more expensive tractor. Many tractors attempting to copy the various features of the Ferguson system have still found it necessary to use a gauge wheel to control the operating depth of the implement. Here we have installed a temporary gauge wheel on the Ferguson plow. It may be adjusted to control the desired operating depth. As we start out plowing, we are still using the Ferguson system, which carries the weight of the plow and soil on the tractor for tractive weight. Some weight is on the gauge wheel, which is rolling along the surface of the ground. The operator now disengages the power takeoff, so the weight of the plow and soil is again gradually lost from the rear wheels and carried on the gauge wheel. As plowing continues, the slippage of the tractor tire becomes very obvious and finally becomes excessive. When the operator re-engages the power takeoff, the necessary traction is obtained to continue plowing. Now let's watch this again. The operator disengages the power takeoff lever. Rear wheel traction is gradually lost, and wheel slippage becomes excessive until it finally results in wheel spin. Re-engaging the power takeoff lever to make the Ferguson system effective gives the tractor the necessary traction to continue normal plowing. Another feature of the Ferguson system is that it protects the implement, tractor, and operator when striking a hidden obstruction. Steel stakes are accurately positioned so that both plow points will strike the middle of the stakes at the same time. The stakes are leaned slightly toward the direction from which the plow will be approaching, so that the plow points cannot slide over or around the stakes. The stakes are driven firmly into the ground until they are hidden below the surface, forming a solid barrier of steel. This should be a brutal treatment for the unsuspecting plow. Watch closely as the tractor and plow approach the stakes at full plowing speed. You will see the impact, which compresses the master control spring, dropping the plow weight and allowing the rear wheels to spin with no damage to the plow or tractor. The operator simply raises the plow as he backs up, drives over the obstruction, and continues plowing without the necessity of reattaching the plow, resetting a safety trip, or replacing damaged parts. If you desire to bring the obstruction to the surface, it may often be done by raising the fingertip lever as the tractor pulls slowly against the obstruction. When we examine the plow points after this rough treatment, we find no evidence of damage, proving that the built-in exclusive Ferguson safety feature does protect the implement when striking a solid obstruction. This view shows the demonstration area with the center being narrowed down for a finish or dead furrow. The Ferguson tractor and plow are ideally designed for making a narrow, shallow, dead furrow that is easily filled in to form a level seed bed. As the land becomes narrower, the operator must straighten the furrows and get both sides parallel. Note the ease of raising and lowering the plow at the end of the furrow by means of the fingertip control lever. When the land is narrowed to the finish, the operator drives the tractor to leave just the amount of land he requires for his final finishing operation. With a two-bottom 14-inch plow, he straddles the remaining land, keeping the left wheel against the furrow wall. He tilts the plow with a convenient leveling crank to make the rear base plow shallow. On his last pass, the narrow strip is turned with the front base, and the rear base, now tipped slightly deeper, recuts the same furrow that it made on the last pass. The result, a neat, narrow, shallow, dead furrow, easily filled in to form a level seed bed. The operator is now plowing the sides of the demonstration lot to form a back furrow or strikeout on each side. Again, note the ease of raising the plow at the end by simply pulling up on the fingertip control lever. This same simple, effortless operation lowers the plow to the desired working depth. Note that the exclusive floating furrow wheel permits quick penetration of the plow as it enters the furrow. Here is just one more feature that is appreciated by many operators when changing plowshares. Removing the top link and driving forward slowly, the plow is turned up on its end. After locking the brake, the shares may now be changed while working in a convenient, comfortable position. The Ferguson tiller is more than just a field cultivator. It is a sturdily built implement capable of completely tilling the soil from a hard, rough, trashy condition to a completely pulverized seedbed. It may be equipped with a wide variety of sweeps and shovels, including alfalfa teeth for pasture renovation, reversible teeth for general tillage, duckfoot sweeps for stubble tillage, as well as spear points and chisel points for special tillage jobs. This type of implement is generally used with large, heavy tractors because of the power and traction required to pull it through the soil. However, with the Ferguson system of implement control providing the necessary traction, it is possible for the Ferguson tractor to handle this heavy load with ease. There is no hesitation or wheel slippage as the implement is lowered into this untilled soil. After working the field in one direction, it may be worked crossways to provide a deeper seed bed of well-mulched soil. This type of farming is well suited to all parts of the country, as it destroys weeds, provides deep cultivation, and mixes trash into the surface for better aeration and moisture penetration. It is also recommended practice for soil conservation to minimize the loss of topsoil through wind and water erosion. These spring-loaded tines are designed to penetrate deep into the soil. Digging into the soil prepared by the cross-tillage, we find the desired mixture of soil and surface trash. It is also evident that the soil has been thoroughly tilled to a depth of 6 to 8 inches to form an ideal seed bed. Let's see what the Ferguson system does with this implement. Man, that is a load. It's just like pulling a cat by the tail. As soon as the operator disengages the power takeoff, the loss of tractive weight is immediately experienced and the wheels spin. Re-engaging the power takeoff to again make the Ferguson system effective gives the necessary traction to pull this heavy draft implement through the heavy soil. Thus, the Ferguson system provides the necessary traction when a heavy draft implement is being used. The Ferguson lift-type tandem disc harrow. This is another sturdy Ferguson implement designed to work with the Ferguson system. It is available in 6, 7, or 8-foot widths with 16 or 18-inch discs that may be either cut out or plain on the front or the rear gangs. It has a special type of bearing which will withstand abrasion and the heavy loads that this deep-cutting implement places upon them. It is raised and lowered by means of the fingertip control lever. Thus, it may be quickly and easily transported to and from the field, as well as raised to cross grassed waterways or to get out of soft or wet spots in the field where a pull-type harrow would not dare to venture. A cement weight may be added to the weight box at the front to increase the penetration if required. Most disc harrows are considered to be rolling implements that are pulled over the land. The Ferguson harrow is again different. As it is pulled forward, the top link is pushed against the master control spring to give automatic control through the Ferguson system to provide that added traction when required. As the operator is disking, he reaches down and disengages the power takeoff. Immediately, the rear wheels spin, showing the loss of tractive weight. Re-engaging the power takeoff, the tractor moves forward to do a disking job that only a much larger tractor could equal. The Ferguson disc harrow is equipped with two levers that are easily reached from the tractor seat. One lever adjusts the angle of the front gang, the other the angle of the rear gang. With no angle in the front gang and full angle in the rear gang, we are ready to close the dead furrow down the middle of the demonstration plot. Driving the tractor straight down the middle of the dead furrow, the soil is drawn back into the depression by the fully angled rear gangs. Here, with a single pass, we see the dead furrow filled in with mulch soil to form the desired seed bed. Raising the harrow, the operator takes all the angle out of the rear and puts full angle in the front gangs. Now he is leveling off the crown of the back furrow or strikeout. Remember, this ridge was purposely made very high, and with a single pass, it is flattened to leave that level seed bed which is desired. The operator now puts a slight angle in the front gang and full angle in the rear gang. Driving down the center of the other highly ridged back furrow, he pulverizes the surface while still leaving a high ridge. This ridge will be used in a later demonstration. The Ferguson rigid tine row crop cultivator. The white stakes shown are arranged to represent 4 rows of corn to be cultivated. A close-up view of the Ferguson rigid tine row crop cultivator shows the exclusive Ferguson steering fin. As the cultivator attempts to sway from side to side, the fin holds on firmly to the undisturbed soil below the cultivating depth. It is this fin that makes accurate rear-type cultivation not only possible, but very desirable. After locating the marker on the front axle so that it will be directly over the right-hand row, the operator drives so that the marker follows the row. The Ferguson linkage is designed so that the implement at all times is following the direction of the front wheels. With the fin acting like the rudder on a boat, it is possible to cultivate along contoured rows with confidence that the cultivating job will be done accurately. This is the back furrow ridge, which we did not level down. The stakes outline the ridge more clearly. Cultivating along this ridge again demonstrates the flexibility between tractor and implement, while maintaining complete control of the implement at all times. Watching this from the rear, we see the linkage rise and fall, maintaining the cultivator at a uniform depth as the ridge is crossed. If the cultivator were a rigidly attached unit as shown in this illustration, and if the front wheels of the tractor dropped into a depression, the cultivator would be pulled out of the ground. When the rear wheels dropped into the depression, the cultivator would be forced down deeper. In this position, the tractor wheels would likely spin, and that's where it would stay. A light tractor for light work, a heavy tractor for heavy work. The relatively light, maneuverable Ferguson tractor permits easy, economical operation for light work while being capable of doing the heavy work when required. Many of us have pushed a bicycle across a tilled field. It wasn't too difficult and didn't take a great deal of energy, did it? That's why a light tractor is more economical to use on a light field job. But try to push a motorcycle across the same field. That's hard work and takes plenty of energy. The same is true with a heavy tractor. It takes much of its power and a great deal of fuel just to move its own weight across tilled soil. There are many other features of the Ferguson tractor, like the ease of getting off or on. Just one short step and the operator is in the seat and ready to go. The roomy step plates and tilt-back seat permits the operator to stand and drive the tractor with the same convenient ease. You will see many of these modern Ferguson implements at field demonstrations. This is the Ferguson tiller that you watched perform in the demonstration. The wide spike-tooth harrow with folded wings for ease of transporting through gates or along roadways. The Ferguson subsoiler with the underground pipe and cable layer. This is a remarkable tool you will want to see more of. The three-bottom 14-inch moldboard plow that covers the acres in a hurry. The lift-type tandem disc harrow that we were watching in the demonstration. The new Ferguson high-speed mower with Dynabalance drive for quiet, smooth mowing. The most advanced mower design ever to be offered the American farmer. We hope that you have enjoyed this demonstration, and we again invite you to ask for a demonstration on your own farm.